Good afternoon, and today I'll be speaking on behalf of the microRNA work group. I will give an update on the current work that is done by the group. And yes, Peter, please, if you have anything to add, please feel free to add. So microRNA work group was formed more than 10 years ago at the very dawn of microRNA as potential biomarkers, and it has had multiple members from both public and private sector, and had wonderful accomplishments, which resulted in publications, peer-reviewed journals, publications on quantification of microRNA biofluids and a microRNA body atlas, as well as recent review by Brian on methodological considerations for measuring microRNAs, and also microRNAs, urinary microRNAs that was published by Poma Nephrotoxicity Group.
Sorry, Tatiana, do you want me to keep moving on, or do you want to go back to that slide?
No, that's good. This is perfect. So today's agenda includes the recent achievements of the microRNA work group in 2022. We'll briefly give an overview of the status of a normal microRNA study. Then also briefly talk about in vitro microRNA study, and we'll have some time for questions and discussion. So the overall goal of the microRNA biomarker work group is to develop confidence in methods to measure microRNA biomarkers in biofluids, also to identify either individual microRNAs or microRNA panels that could be used together with other biomarkers to predict organ toxicity or disease. But I think overall, the goal is to influence implementation of microRNAs as novel biomarkers of toxicity.
Yeah, and Tatiana, sorry, there's just a brief comment. It's a little bit muffled. I can hear you all right. If there's any way to maybe move your mic, that would be appreciated. But if not, I think it's manageable.
I will try to do that.
Oh, that's a little better now. Maybe even just closer, whatever you just did.
Yeah. I just have a headphone that I don't normally use. It's a bit different one. Is it better now?
Yes, that is for me. Thank you.
Okay, so very briefly, the accomplishments include finalizing a adversarial microRNA study. Some additional samples were analyzed. And the results of our external microRNA studies were presented at ICM meeting. Brian presented this poster, and I think he even had a small virtual oral presentation on that as well. And also a finalized design and plan for microRNA in vitro study. And we started a conversation on the potential next steps for the group. So I wanted to, I don't see one of the tables here. I just wanted to briefly mention two recent papers by Brian. One of them measurements of microRNAs in biofluids, and the other would be the effort led by Charles Cotier on segment-specific microRNAs of nephron. So both papers, they paved the road for the current exosomal work that we're doing. So, Brian very well outlined in a paper the major gaps and challenges that exist on the way of microRNAs to become widely accepted biomarkers. Those challenges include biologic and technical challenges. And I think with the exosomal study, we try to address mostly a biologic challenge, how microRNAs are released into biofluids. Everyone knows that microRNAs in biofluids exist either in within exosomes or in an exosome-free fraction, often as protein complexes. And so there is overall uncertainty how microRNAs are released during tissue injury and how tissue injury does affect the process. So the goal of the study was to determine if analysis of exosomal fraction would improve microRNA biomarker performance and also inform on biological mechanisms that mediate microRNA release. And objectives included assessment of its normalization to exosomal counts would reduce variability and improve microRNA signal in urine, and also to analyze if exosomal microRNA fractions can improve signatures of renal toxicity. The experimental plan included extraction and count of exosome from urine of nephrotoxicant-treated animals. It was done by Peter at NIH. Then quantified selected microRNAs in exosomal fraction by RT-PCR. Was done here at AbbVie, and analyzed data and compared to whole urine results. The analysis was done by Brian at EPA. So this is a background for the study that was used for in vivo study that was used for exosomal analysis. Monkeys, the study includes monkeys that were dosed with an AbbVie developed compound that was found to be a nephrotoxicant. There were a few advantages to this study. First of all, monkeys had a distant histologic lesion in collecting ducts. So for this study, the urine was collected in a timed manner, and urine protein biomarkers were analyzed. The study, and we also obtained whole urine data from that study, and also high urine volumes were available from that study that would allow for exosomal isolation. So very briefly on the study design here, monkeys were dosed with 2 doses of the compound. With 200 micrograms per microliter and 300. 300 dose was dosed just once, and 200 was dosed twice on day 1 and on day 21. So several animals for each treated group were necropsied on day 21, while the rest animals were observed up until week 13 when there was a necropsy performed of the remaining animals. Urine was collected weekly, and 4 time points, which include week 1, 4, 8, and 12, were selected here adapted internally for whole urine microRNA analysis. The compound selected is known to cause delayed renal toxicity. So we really expected, and we confirmed a lot of histological changes after 12 weeks upon dosing. So very briefly, histopathologic changes, it included mostly tubular degeneration and single cell necrosis, minimal to moderate. And also we observed elevation in several protein biomarkers in urine, which included clustering and cystatin C, and also both clustering and cystatin C correlated with the histopathology results. Also, in the study, the microRNAs were analyzed in whole urine. We analyzed 29 different microRNAs from 3 random animals from the control and each treatment group at selected time points, with 1, 4, 8, and 12. Post dosing, the RT-PCR was used. So microRNA measures in whole urine did not show any clear nephrotoxicity specific pattern due to very high sample-to-sample variation and lack of correlation with histopathology. And normalization of this microRNA data to
Next slide. Oh, are you good here, Tatiana? Tatiana, I don't hear you anymore. Do others? Sadaf, can you hear her?
No, I don't hear her either.
Oh, let me send a note. She's unmuted. I'm not certain what happened. Oh, we lost the connection. There's Peter.
Is this too noisy? Can you hear me?
I hear you okay. I'm either happy to walk through and you can fill in, or either way. What would you like to do, Peter? Do you want to try? Maybe.
Yeah. Might be a little tough.
Oh, there's Tatiana again. Maybe she got disconnected. Apologies, everyone. Okay.
no, I apologize. Yeah, there was a disconnect. My computer. Sorry about that. I can pick up for normalization to second my microRNAs CL 39 and 54 and or to create an did not improve the variation. So our conclusion that was that microRNAs in urine, in whole urine, did not perform as biomarkers on the toxicity. So for the episomal study, out of this 29 microRNAs, I can see all of them. I don't know, this is like pictures that delayed here. Okay. So we have selected 6 microRNAs based on some trending alterations in whole urine, sometimes very significant, and also on previous nephron segment localization data. So the microRNAs listed at near 423, near 143, near 486, 130B, 193A, and 210. So for the episomal analysis, remaining urine samples from the selected animals and time points, same for time points for sent to NIH, National Institute of Diabetes and Digestive Kidney Disease. For episomal isolation count, episome count was obtained using nanoparticle second analysis by Peter and his group. Episome prep was sent back to AbbVie for PCR analysis. Selected microRNAs. As I mentioned, microRNA panel was selected upon a thorough discussion by the group members, and RNA extraction and PCR methods were identical to those previously used for the whole urine analysis. And raw files with the fluorescence data were sent to USPH to Brian Foley for analysis. He used initial fluorescence estimation method, raw method, to quantify selected microRNAs in both episomal and whole urine fractions. So the first of the questions that we wanted to answer, if normalization to some count would reduce variability. So here you see the data from all microRNAs. It's presented as estimation, fluorescent estimation, or ROM values across all samples and all time points. So without any normalization, for autosomal microRNAs, coefficient of variation was 292. So here on the right upper corner, you can see the autosomal count for all samples and all time points, which shows a quite high sample-to-sample variability. And the overlapped corner, this is microRNA estimation, which was normalized to spikes in microRNAs, and the coefficient of variation was not improved. And in lower right corner, this is microRNA estimation data normalized to autosome count. So we can see that the coefficient of variation was slightly decreased. So sample variation was attenuated by slightly attenuated by normalizing the autosomal count, but did not change once normalized to spike in microRNA. So this is the microRNA analysis comparison between whole urine and exosome fraction. Again, the data is represented as fluorescent estimation. So this is data for microRNAs 143, 423, and 193. So so ecosomal microRNAs when normalized to autosomal concentration showed more significant alterations in urine, and also sometimes changed directionality for some microRNAs, as seen at week 12 here from year 143 and 422. So this is the microRNA analysis data for another 3 microRNAs, microRNA 130B, 210, and 486. So I think the conclusion is similar to the previous one. Some more significant alterations and treated animals versus control were seen in autosomal fraction, and some similar reduction over time was also observed in autosomal fraction. So summary and conclusions here. Normalization of urinary microRNAs, so exosome count slightly reduced sample-to-sample variability. However, autosomal microRNA measurements were still highly variable between animals. Despite this, we see a greater significance and difference between control and treated animals when measuring exosome-derived microRNAs. And the change was in a different direction, indicating an overall reduction in the signal for some targets. Significant mutation of urinary exosomal microRNAs 210 and 183 by 12 weeks of exposure was observed, which is in contrast with the trending increase in these microRNAs in whole urine. This data suggests that exosomal packaging of microRNAs may be influenced by renal toxicity, and that exosomal microRNAs may be a more fine and less variable novel biomarker of nephrotoxicity. Current data, as I mentioned, was presented at the ICM meeting, and next step is publishing this data. We started working on a manuscript preparation, which we plan to submit to special issues of the International Journal of Molecular Sciences, the role of non-coding RNAs in kidney disease, and hopefully we can do this in early January of 2023.
Great, thanks,
yeah.
Oh, go
Also,
ahead,
thank you
please.
everyone who was involved in this effort. And thank you, Brian and Peter, and for conducting the study, participating in the study, and Connie, thank you for keeping us going and raising the meeting, and everyone from my community group for their feedback.
Thanks, Tatiana. And Peter had a comment he sent to me that the information from the exosomes is probably different than in the non-exosome fractions of the urine, where some exosomes contain information from intact cells, whereas non-exosomal information is largely from dead or damaged cells. So it is important to point that out where those microRNAs are coming from potentially. Peter, did you have anything else to add to that piece? Alone or in combination. You can add in that we are analyzing correlations between the histopath in individual animals and of the urine biomarkers as well. So trying to compare those more traditional biomarkers to what we're seeing in the urine that's normalized to the exosomes. So thanks both for that. I'm gonna quickly go through the in vitro study. This work is really being led by Peter, who you can see is at another conference right now, and then also Colin, who's been traveling as well. So I'm just gonna briefly give a snapshot of it. But in continuing the work, a lot of the work so far has been done in vivo on existing samples. What we really wanted to look is, the translation to in vitro, but also to get some more mechanistic information. So in this study, we want to see if microRNAs can be used in an in vitro system to predict kidney damage. And I'll go through what we're doing, but basically we're going to expose cells to 2 known nephrotoxicants using a human kidney platform, and then quantify the microRNAs that are released. So some scientific questions this work can answer. Do changes in microRNA levels correspond to time and dose-dependent nephrotoxicant exposures? How do the in vitro microRNAs, both the types and the quantities, compare to our in vivo studies? And also, is there polarity of the microRNAs release? And we're able to answer that last question because of the model we're looking to use. It has both an apical and basolateral side. We're using a human model in this case, but we're going to measure both the microRNAs. We have the potential to look at the exosomes, but then we're also going to look at the more traditional biomarkers to try and compare. And here's just a little bit of study details. We're short on time, so I won't spend too much time, but 2 known nephrotoxicants, so cisplatin and polymyxin, they're a basolateral and apical nephrotoxicant, so we have 1 of each type. We're doing multiple concentration and time points, and we're also doing multiple replicates, but also donors from the human side and the different collection sites, so the apical, the basolateral, and that intermediate. We're comparing to some of the traditional injury markers. We're going to do some high content imaging, but then we will also ship the samples for the qPCR to compare the microRNAs. So that's an ongoing study. We hope to have this done in the next couple months and share some preliminary results with the group. In terms of outreach, we actually already said, but Brian had presented a poster earlier this year. For the in vitro work, we're also submitting an SOT abstract. So we hope to share some of that initial data in March next year. Just some real quick, that we have these exosomal study finishing up. We're writing it up right now with the team. We're going to have the in vitro study that's probably going to give us a lot of information, but then we are at somewhat of a crossroad, and here is where we could get feedback from the folks on the line of future directions. I think there's still a ton to do in this space, but if this is something that people have ideas or there's projects that they have interested in, please feel free to reach out to me and to our leads. We had talked about in the team, I believe on our last call, some potential areas. I won't go through them all in details, but we could really dive in and get some mechanistic information on these microRNAs. It's not always known, and Peter had pointed out, where they're coming from. Is it from a certain place within the body? Is it kind of a response that's endogenous or it's due to some kind of chemical exposure or stress response. So kind of understanding how the microRNAs are moving and what they maybe do endogenously. So links to the intracellular changes. We could further look at some of the panels that we've been testing, so that we talked about in the exosomal study. We could look at cross-species conservation. Their microRNAs are thought to be pretty well conserved. Or there's different types of mRNAs, so like tRNAs, piRNAs, etc. So we're close on time. Maybe Tatiana or Peter, anything else from you before we conclude today? And maybe we have a few questions if there are any.
Well, I just wanted to comment that the shRNAs are a lot easier to do in vitro, but then those could be followed up with microRNA specific compounds in vivo.
Thanks, Peter. Tatiana, anything else from you?
No, thank you. I think we that's it. I think looking forward to some discussion on potential next steps.